Hello. In this lecture we will discuss dead peer detection. This is negotiated in the vendor ID attributes. What dead peer detection allows you to do is to preemptively check and see if the other side of the connection is available and reachable, even at times when you don't have traffic to send. So this is achieved by sending hello and acknowledgement messages between the peers. And each peer is independent of each other. So one side can send dead peer detection, and the other side doesn't have to have the dead peer detection configured. It could be from one side only. By default, Cisco has the dead peer detection in the vendor ID list. So the two messages, "Are you there" message, and "Are you there" acknowledgement message. And this will be encrypted because this is after phase 2 gets established. So it's kind of like a ping to verify the other side is live and kicking. Okay, so we have the two routers here that has an IPsec tunnel in between. I'm going to capture the traffic. And we are going to create a tunnel by pinging the other side. So, the tunnel is established. If we look here, by default, the Cisco routers negotiates the dead peer detection. And we see here that the third message says dead peer detection is enabled. So that means if one side initiate the dead peer detection, the other side would understand that this is a feature that was negotiated, and it will respond to the messages. So by default, it's supported. But it's not enabled to do periodic checks. When the router does periodic check, it actually sends a keep alive every how many seconds you specify, and it sends message to the other side. So, the importance of this is if the other router got recycled, if you don't have your router set for sending periodic keep alive, what happens is the phase 2 would be stuck, because the other side is not responding. So let's go ahead and simulate that. So we have a tunnel connection between the two routers. I'm going to go ahead and restart the remote router. Stop, start. OK. And right now router 1, crypto ISAKMP SA still has the ISAKMP SA established. If we do show crypto IPsec SA, it still have the SA for phase 2. So, if I try to initiate traffic from this router to remote router, it will not go anywhere. So what happens here is that your side of the tunnel is still up. Your router didn't realize that the remote side went down. And during that time, the router will keep sending ASP traffic to the other side without realizing the other side was reset. Remember, we mentioned in a previous lecture that if the router gets an ASP packet with an SPI that is not in its Security Association database, the router will discard the packet. The remote router will actually keep rejecting the ESP traffic and not respond since that's what the RFC specifies. So, this becomes a catch-22 situation. If your router is the side that initiates the connection, and the other side is not initiating a connection. This scenario happens a lot in situation where you have hub and spoke tunnels, where the spokes are the ones that initiate the connection. The hub will not initiate a connection to the spoke. The spoke will keep sending the packets with ASP encapsulation, and will not hear anything back. It will stay stuck. So to make sure that we don't get stuck in a situation like this, we need to have our router catch this situation where the other side dropped the connection. For us to catch this, we have to configure dead peer detection with a periodic check. And when you specify periodic check, if the other side doesn't respond, your side will clear the connection. This would open the way for a new negotiation of IPsec to take place. In our case here, still both the IPsec SA is there, and the ISAKMP SA is there. So, let's simulate that scenario with the periodic dead peer detection enabled. Okay, so now router 2 is back up. I'm going to clear the crypto session and enable periodic crypto ISAKMP keep alive. We will specify that the router will send an "Are you there" message every 10 seconds. We will also specify that if 2 "Are you there" messages didn't get a response, that our router would consider the tunnel dead and renegotiate. Okay, so let's go ahead and enable it. We will configure crypto ISAKMP keep alive to send every 10 seconds, and declare the tunnel dead after 2 missed dead peer detection messages. Let's go ahead and re-establish the tunnel. Okay, so now we have the tunnel established. I configured this setup to use authentication header so we can see the payloads. We see here that periodic dead peer detection are being sent. This is the informational message that carries the dead peer detection. And it's going to get sent every 10 seconds. So after 20 seconds, if the other side doesn't respond, it's going to clear that session. So, it's going to be much faster at detecting that the remote peer is no longer accepting its ESP packets. So let's go ahead and stop and restart the remote router. And we'll see now what happens. So, the information messages are sent. The second informational message didn't get a response. And now, the router is going to delete that session because it missed 2 keep alives. So this makes the actual recovery from such a use case way faster. We will discuss more in the next lecture.